Welcome to our lecture on control systems with electronic ignition. As energy costs rise and the need for efficiency grows, the gas industry has largely moved away from the old standing pilot lights. Today, we use electronic ignition systems that only light when needed, saving energy and reducing those expensive service calls caused by wind or rain blowing out a pilot.
Just like basic control systems, electronic ignition setups rely on four main circuits. The control circuit uses 24-volt power from the thermostat to start the process. The fan and transformer circuits handle air movement and voltage reduction. But the real star here is the combustion safety circuit, which electronically monitors the flame and can react to a flame failure in less than 1 second.
There are four primary components that make these systems work. The control module is the brain, sequencing the entire light-up procedure. The igniter creates the spark or heat to start the fire. The flame sensor acts as the eyes, detecting if a flame is actually present. Finally, the redundant gas valve provides the fuel, using a double valve design for an extra layer of safety. To understand how a system knows a flame is present, we have to look at flame ionization. When a flame burns, the intense heat causes air molecules to collide forcefully, knocking electrons loose and creating ions. If we place two electrodes in that flame and apply a voltage, those ions will actually conduct a very small electrical current right through the fire. Early systems used alternating current, but they couldn't tell the difference between a real flame and a short circuit caused by carbon buildup. Today, we use a flame rectification system. By making the ground electrode at least 4 times larger than the flame rod, the flame conducts electricity much better in one direction. This turns the alternating current into a pulsating direct current, which the module easily recognizes as a true flame.
When dealing with control modules, you will hear a few key terms. Trial for ignition is the specific window of time the system allows to establish a flame. If no flame is proven in that time, the system goes into lockout, requiring a manual reset. Finally, flame failure response time is how incredibly fast the sensor reacts to a lost flame and shuts off the main gas valve.
Let us look at the first of 3 main module types, the intermittent pilot. When the thermostat calls for heat, the module does a safe start check, then sparks the igniter and opens the pilot valve. Once the sensor proves the pilot flame is lit and stable, it stops sparking and opens the main gas valve. The pilot only burns while the main burner is running. Next is the direct spark ignition system. This setup skips the pilot entirely. After the safe start check, the module simultaneously sparks the igniter and opens the main gas valve. The spark directly ignites the main burner. Once the sensor detects the main flame, the spark turns off, and the system monitors the fire for the rest of the heating cycle.
The third type is hot surface ignition. Instead of a spark, this system uses standard line voltage to heat a special element until it is glowing red hot. The module gives the igniter about 30 seconds to warm up, then opens the main gas valve. The gas ignites on contact with the hot surface. The igniter powers down, and the flame sensor takes over monitoring.
Many modern systems include a fan assist burner or combustion air blower. In these setups, the module turns on the blower first. The airflow must physically close an air proving switch to confirm the exhaust path is clear. This triggers a pre-purge timer to clear out any leftover gases before the ignition sequence is even allowed to begin. As a technician, you must be able to read electrical ladder diagrams to troubleshoot these sequences. You read them from left to right, from the hot line to the neutral line. Switches are almost always located on the hot line. By tracing the path, you can follow the exact order of operations, from the thermostat closing to the draft motor starting, right down to the main burner firing. Today, many units use integrated furnace controls. These are solid-state boards with built-in microprocessors that manage the entire furnace, eliminating the need for separate external relays. They also feature system fault analysis. If a safety switch trips or a flame is lost, a diagnostic LED will flash in specific patterns, like 3 flashes for a pressure switch error, telling you exactly where the problem is. To wrap up, electronic ignition systems provide safer, more efficient heating by eliminating standing pilots. Remember that they rely on flame rectification to accurately prove a flame exists. Whether you are working with an intermittent pilot, a direct spark, or a hot surface igniter, understanding the sequence of operations and how to read integrated diagnostic codes will make troubleshooting highly effective.